Hi everyone, welcome to Algorismo. I'm Atik and I'm excited to have you here. Are you trying to learn programming and algorithms but finding it challenging to grasp the concepts? You're not alone, and that's exactly why we created this series. Whether you're looking to expand your existing programming skills or brush up on your knowledge, there is something here for everyone. We'll assume you have a basic knowledge of programming. While you can use any programming language to learn about algorithms, we will be using Python in this series. So let's get started on this exciting journey together. So what's the purpose of Algorismo? Well, we have three main goals. First, we want to simplify complex algorithms. Algorithms can seem intimidating, but we will break them down into easy to understand steps. Second, we aim to provide practical examples and real-world applications. You'll see how these algorithms work in real-life scenarios, making the concepts more tangible and relevant. And finally, we want to help you build a strong foundation in computer science. By the end of this series, you will have a solid understanding of key concepts that will set you up for success in your coding journey. So what will we cover in this series? We will begin with simple tasks like searching for a number in a list or sorting a list of names alphabetically. Then we will move on to examples that require more complex organization, like keeping track of tasks in a to-do list or organizing files on your computer. As the series progresses, we will tackle problems that need more advanced data structures and algorithms, such as planning routes on a map or interpreting weather forecast. By the end of this series, you will understand how to approach a variety of programming challenges with confidence. So what exactly is an algorithm? An algorithm is a step-by-step procedure for solving a problem. Think of it as a recipe for your computer. And we all know how important it is to follow recipes, right? Ever tried making a cake without one? Yee, not pretty. Let's take a simple example, making a sandwich. Here's how we can break it down into steps. Take two slices of bread, spread butter on one slice, add cheese or ham to the buttered slice, add lettuce if you like, place the second slice of bread on top, your sandwich is ready. Each step is clear and follows a logical order, resulting in a perfect sandwich. Imagine if we mixed up the steps and messed everything up. As you can see, not following a well-defined and logical step-by-step procedure results in a mess. Same happens in programming. Algorithms ensure we achieve the desired outcome correctly and efficiently. Algorithms are everywhere, silently making our lives easier. They help you find the quickest route to work, filter spam out of your email, recommend the next book or movie you might enjoy, and even predict the weather. Without algorithms, we would be lost in a sea of information and inefficiency. Think about trying to find the best price for groceries or navigate busy city streets manually. That's how crucial algorithms are in keeping things running smoothly. To create effective algorithms, there are a few key traits to keep in mind. First, an algorithm must be correct. It should solve the problem accurately. No one likes a recipe that turns your cake into a brick. Efficiency is also critical, ensuring the algorithm saves time and resources. No one wants a recipe that takes 3 days to make. Other important characteristics include being finite, meaning it has a clear end, being clear and easy to understand, and is general enough to work for many problems. But for now, let's focus on ensuring our algorithms are correct and efficient, and you will understand other concepts better as you move on. Every algorithm has three main components: input, the data provided to the algorithm; output, the result produced by the algorithm; and Steps or process, the sequence of instructions that transform the input into output. For example, if you're making a sandwich, your inputs are the ingredients like bread, butter, and cheese. You apply a recipe as a process and get your sandwich as output. In a computer, if you're trying to find the student with the highest grade in a class, our simple inputs could be student grades. Next is the steps or process, where the algorithm compares each student's grade to determine the highest one. Finally, we have the output, the student with the highest grade. This framework helps us understand how algorithms transform inputs into valuable outputs. Let's see how we can use an algorithm to solve a common problem, finding the maximum number in a list. This example generalizes the problem we discussed earlier, finding the student with the highest grade. Our input is the list of numbers 5, 3, 9, 1, and 6. Now the answer or output is simple, 9. As humans, we might quickly identify the biggest number in a small list at a glance. However, computers have limited perception and capability compared to humans, which is why they need to perform number by number comparisons. This difference in perception and processing is what makes programming challenging to learn at first. However, if we dig deep, we realize that we also do the whole process. Adopting this methodical way of thinking is crucial for writing effective algorithms. So the process involves comparing each number to find the maximum. We start with the first number as max, that is 5. Then we compare the max with the next number, that is 3. As 3 is smaller than the current max, so no update is needed. Next we compare max with 9. Since 9 is bigger than the current max, we update max to 9. Comparing this newly identified max with the next numbers 1 and 6 does not result in any update. Finally, our output is the maximum number, which is 9 in this case. So assuming the first number is max, we compare each subsequent number to the current max and update the max if a larger number is found. This process that takes the input list of numbers and then outputs the maximum number of the list is our algorithm, the first in our series. But how do we describe this algorithm or put it to use in a way that's easy to understand and implement? One effective method is using pseudocode. Pseudocode is a simple way of writing down the logic of an algorithm using plain language. Let's start with a straightforward description of the steps involved in finding the maximum number in a list. Step 1. Start with the first number, call it max. Step 2. Compare it with each number in the list. Step 3. If you find a bigger number, update max. And step 4. At the end, max is the biggest number. Now that we have described the algorithm in simple steps, let's look at a more formal way to represent it. This method, still a pseudocode, helps us break down the algorithm into clear, structured steps that can easily be translated into any programming language. Here is how we can describe the algorithm for finding the maximum number in a list using pseudocode. We name the algorithm findMax, announcing that it will take a list of numbers as its input and will output the maximum number in the list. As we begin the actual process in the algorithm, we initialize the max variable to the first number in the list. This aligns with step 1 from our simple pseudocode. Next, we loop through each number in the list and compare it to the current max. If we find a larger number, we update max. This aligns with the second and third steps from our simple version of pseudocode. Finally, after all the numbers in the list are compared, we return the maximum number as the output. This aligns with the final and fourth step from our simpler version of pseudocode. But will this work on a computer? Well, not quite. While pseudocode is great for understanding the logic, we need to translate it into a programming language to run it on a computer. We choose Python because it's beginner friendly, widely used, and has a simple syntax. Let's start with the basic implementation of our algorithm to find the maximum number in a list. Here we translate the pseudocode into Python. We start by defining a simple list of numbers containing 5, 3, 9, 1, and 6. We then initialize the max number variable to the first number in the list. Next, we loop through each number in the list and compare it to the current max number. Python has this sophisticated way of looping using the in operator that automatically takes a number from numbers list and assigns it to the variable number for use inside the loop. If the number is larger, we update max number. Finally, once the loop ends, we print out the maximum number. Let's try running our code to see it in action. There are lots of online and offline tools available for running and testing code, each with its strengths. We will begin with Python Tutor, an online tool that helps visualize the execution of our code step by step. This makes it perfect for understanding the flow of our algorithm. First, go to the Python Tutor website and enter your code in the code editor. Python Tutor is especially useful for beginners because it shows exactly how the code runs line by line. Here is our code. Click the Visualize Execution button to see the code in action. Python Tutor will step through each line of code showing how the variables change and how the flow of the program works. Let's walk through the execution of our code step by step using Python Tutor. The code begins execution. The initial list numbers contains 5, 3, 9, 1, and 6, and we can visualize it as an object here. Next, the variable max number is initialized to first number in the list, which is 5. Then the for loop begins, and the first number, that is 5, from the numbers list is compared to max number. Since 5 is equal to max number, there is no change. You can visualize the content of both max number and number variables here. Next, the loop proceeds to the next number, 3. It is compared to max number. Since 3 is less than 5, there is no change. Moving on, the loop proceeds to the third number, which is 9. It is compared to max number. Since 9 is greater than 5, max number is updated to 5 in this case. The comparison with next two subsequent number 1 and 6 does not result in any update in the max number. Once the loop finishes, when the number of elements in the numbers list expire, it comes down to print the max number variable, and it prints finally the max number is 9. Now let's take our basic Python code and convert it into a function. Using functions in programming is crucial for several reasons. It makes our code more organized, reusable, and easier to understand. Here's how we can convert our algorithm for finding the maximum number in a list into a function. We begin with the code that we have already written. Next, we remove the list of input numbers from the beginning and the output statement that prints the maximum number. Notice that the algorithm is still intact. As the next step, we shift the input list and output print statement to the end of the code. Now we write the function header. The def keyword is used to define a function in Python. Findmax is the name of the function we have chosen, and numbers variable inside the parenthesis represents the input this function receives. Notice that our previous code, now part of this function findmax, is indented. This indentation ensures that this piece of code is part of the function findMax, also known as the body of the function. One more thing, we must add a return statement at the end of this function to ensure that findMax can output the biggest number that it finds in the input list. Now that we have defined the findMax function, we need to call it. As you can see, the input list of numbers named sample numbers is defined below. We call this function findMax with the list sample numbers passed as input to this function. This call will execute the findMax function on this input list. You may notice that the name of the list when calling the function is sample numbers, whereas the name inside the function header is just numbers. This is perfectly alright. You may choose the same or different names. Formally speaking, the inputs specified in the function definition are parameters, and the inputs given when the function is called are arguments. Next, after processing the input list, the function will return the max number it finds in the list. The max number takes the place of this function call and is printed here. In short, a function wraps an algorithm's logic with clear input and output interfaces. To conclude, this is the function definition where we have written out the algorithm to find the maximum number from a list of numbers. And this particular is the function call. Let's try running this modular code to see how it works. Let's walk through the execution of our function-based code step by step. On line 1, we define the function findMax with numbers as the input list. This line creates the function object findMax but does not execute it yet. The control goes to the next line following the function body, that is line 8, because the function will only execute once it is called. On line 8, we define the input list sample numbers with our sample values, and you can see the list created as an object here. On line 9, we call findMax function within the print statement with sample numbers as input. When the function is called, the control goes back to line 1. You can see both sample numbers and numbers list pointing to the same object in the memory. These are called aliases. Now the function starts executing and does the same processing explained earlier. Once the loop ends, max number contains the maximum value from the list, which is 9 in this case. The function returns max number to the function call. The function call on line 9 is replaced with the value returned, and the message that the maximum number is 9 is printed as output. That's it. Let's recap what we covered today. We discussed what algorithms are and why they are important. We described our algorithm for finding the maximum number in a list using pseudocode. We implemented the algorithm in Python and saw how it works step by step. We learned how to convert our algorithm into a reusable function. To further develop your understanding, we have provided an exercise. This exercise helps you explore how many steps the algorithm takes to find the maximum number. The solution is available if you need it. You can find the code examples and exercises on our GitHub page. The link is provided in the description below. Next, we will dive into another fundamental algorithm, linear search. We will explore how to search for an element in a list. That's all for now. Thank you for watching and joining me on this journey through algorithms. Don't forget to check out the code examples and exercises on our GitHub page. Your feedback is important to us, so please share your thoughts and suggestions in the comments. See you next time for our lesson on linear search. Happy coding!